Hello, everyone. My name is Willie Robinson, and I have the distinct pleasure of providing you with a presentation on qualitative sampling strategies. I hope that you will find this presentation informative and useful as we all continue to narrow down our research approach to our dissertation. This presentation will follow sort of an outline, beginning with sampling strategies, alternative paradigms, external validity, defining the population and sample strategies more in depth, sample size, and some access issues. Sampling strategies, alternative paradigms. Now, sampling as it relates to research refers to the selection of individuals, units, and or settings to be studied. Whereas quantitative studies strive for random sampling, qualitative studies often use purposeful or criterion based sampling. That is, a sample that has the characteristics relevant to the research questions. For example, if you're interested in studying adult survivors of childhood sexual abuse, interviewing a random sample of 10 people may yield only one adult survivor. Thus, you will essentially have a sample size of one and need to continue to randomly sample people and to have interviewed an appropriate number who have survived childhood sexual abuse. This is not a wise use of your time. External validity, or the generalization or transferability. This is where you generalize findings to the target population. And so, in these instances, it is very important that you provide an in depth description about the case. Now, defining the population and sample, you have what we call conceptual definitions and operational definitions. Conceptual definitions use other constructs to explain the meaning. Operational definitions specify how the construct will be measured. Now, through the review studies, the researchers should formulate a formal conceptual definition. For example, a target population would be a first grade students in Georgia. An operational definition of the sample or experimentally accessible population defined as the list of people who fit the conceptual definition, such as all first grade students who are gifted. We have all types of sampling strategies. To start with, probability sampling or non probability sampling, also known as purposeful or theoretical. We have convenience sampling. And to categorize sampling, probability sampling is a category. And in that category, you have simple random sampling, systematic sampling, stratified sampling, cluster sampling, and multi stage sampling. And all of these will be further explained throughout the presentation. To start off with, simple random sampling. This is where each member of the population has an equal and independent chance of being selected. Now, a major pro in this type of sampling is that it's a simple process, but one of the drawbacks is a complete list of the population might not be available, so it may include some outside. Systematic sampling. This is where you select every nth name from the population list. So you have to estimate the needed sample size and divide the number of the names on the list by the sample size. This is an example given, and one of the major pros of this type of sampling is you don't need to have an exact list of all the sampling units. A drawback is if the files are arranged in a specific pattern, that can result in choosing a biased sample. Stratified sampling or, or stratified purposeful sampling. Now, this focuses on characteristics of particular subgroups of interest and it facilitates comparisons quite well. This strategy is similar to stratified random sampling. This is where samples are taken within samples, except the sample size is typically much smaller. In stratified sampling, you stratify a sample based on a characteristic. For example, if you're studying academic performance, you would sample a group of below average performers, and above average performers. The main goal of this strategy is to capture major variations, although common themes may emerge. Cluster sampling. This is used with naturally occurring groups of individuals. And the example that I give is city blocks or classrooms in a school and study all the samples there. A major plus of cluster sampling is you're able to save time and money by collecting data at a limited number of sites. A drawback is you generally have a small sample size, which gives you less precision in estimating the effect. Multi-stage sampling. This is where you combine different sampling strategies. And the example that I give here in the presentation is you combine cluster sampling with random sampling. Excuse me. One of the major pluses of this type of sampling is that it's more reliable. The downfall is you end up with complex calculations. Okay, now I'm going to discuss purposeful or theoretical sampling. These are non probability, whereas the researcher selects their samples with the goal of that it will allow them to study a case more in depth. Now, there's several different types of sampling that are listed on here, and I'm going to give you information on all of them in one way or another through either explanation or through just allowing a slide to um, be on the screen for your own review. But I want you to pay close attention to the ones that are in bold, such as maximum variation sampling, critical case sampling, snowball or chain sampling, criterion sampling, and theory based or operational construct sampling. Extreme or deviant cases. Extreme or deviant case sampling looks at highly unusual manifestations of the phenomenon of interest, such as outstanding success slash notable failures, top of the class slash dropouts, crises. This strategy tries to select particular cases that would glean the most information given the research question. One example of an extreme deviant case related to battered women would be battered women who kill their abusers. Intensity sampling chooses information rich cases that manifest the phenomenon intensely but not extremely, such as good students slash poor students, above average slash below average. This strategy is very similar to extreme slash deviant case sampling as it uses the same logic. The difference is that the cases selected are not as extreme. This type of sampling requires that you have prior information on the variation of the phenomenon under study so that you can choose intense although not extreme. Examples: maximum variation sampling. Maximum variation sampling selects a wide range of variation on dimensions of interest. The purpose is to discover or uncover central themes, core elements, and or shared dimensions that cut across a diverse sample, while at the same time offering the opportunity to document unique or diverse variations. For example, to implement this strategy, you might create a matrix of communities, people, etc., where each item on the matrix is as different as possible from all other items. Homogeneous sampling brings together people of similar backgrounds and experiences. It reduces variation, simplifies analysis, and facilitates group interviewing. This strategy is used most often when conducting focus groups. For example, if you're studying participation in a parenting program, you might sample all single parent female head of households. And here are some other type sampling in qualitative research. Snowball or chain sampling. Snowball or chain sampling identifies cases of interest from people who know what cases are information rich. Again, snowball or chain sampling identifies cases of interest from people who know what cases are information rich. That is, who would be a good interview participant. Uh, Thus, this is an approach used for locating information rich cases. You would begin by asking relevant people something like, who knows a lot about blank? For example, you would ask for nominations until the nominations snowball, getting bigger and bigger. Eventually, there should be a few key names that are mentioned repeatedly. Criterion sampling selects all cases that meet some criterion. This strategy is typically applied when considering quality assurance issues. In essence, you choose cases that are information rich and that might reveal a major system weakness that could be improved. For example, if the average length of stay for a certain surgical procedure is 3 days, you might set a criteria for being in the study as anyone whose stay exceeded 3 days. Interviewing these cases may offer information related to aspects of the process/system that could be improved. Theory based or operational construct or theoretical sampling identifies manifestations of a theoretical construct of interest so as to elaborate and examine the construct. This strategy is similar to criterion sampling, except it is more conceptually focused. This strategy is used in grounded theory study. You would use sample people/incidents, etc., based on whether or not they manifest or represent an important theoretical or operational construct. For example, if you're interested in studying the theory of resiliency in adults who were physically abused as children, you would sample people who meet theory driven criteria for resiliency. Confirming and disconfirming cases. Confirming and disconfirming sampling seeks cases that are both expected and the exception to what is expected. Again, confirming and disconfirming sampling seeks cases that are both expected and the exception to what is expected. In this way, this strategy deepens initial analysis, those that add depth, richness, and credibility, as well as disconfirming cases, examples that do not fit and are the source of rival interpretations. This strategy is typically adopted after initial fieldwork has established what a confirming case would be. For example, if you are studying certain negative academic outcomes related to environmental factors like low parental involvement, high teacher to student ratio, lack of funding for a school, etc., you would look for both confirming cases, those cases that evidence the negative impact of these factors on academic performance, and disconfirming cases, cases where there is no apparent negative association between these factors and academic performance. Purposeful random sampling. Purposeful random sampling looks at a random sample. This strategy adds credibility to a sample when the potential purposeful sample is larger than the one can handle. While this is a type of random sampling, it uses small sample sizes, thus, the goal is credibility, not representativeness, or the ability to generalize. For example, if you want to study clients at a drug rehab program, you may randomly select 10 of 300 current cases to follow. This reduces judgment within a purposeful category because the cases are picked randomly and without regard to the program outcome. Now, sampling politically important cases. This seeks cases that will increase the usefulness and relevance of information gained based on the politics of the moment. This strategy attracts attention to the study or avoids attracting undesired attention by purposefully eliminating from the sample politically sensitive cases. This strategy is a variation on critical case sampling. For example, when studying voter behavior, one might choose the 2000 election not only because it will provide insight, but also because it would likely attract attention. Another example of qualitative research sampling is convenience sampling. Convenience sampling selects cases based on ease of accessibility. This strategy saves time, money, and effort. However, it has the weakest rationale along with the lowest credibility. This strategy may yield information poor cases because cases are picked simply because they are easy to access rather than on a specific strategy or rationale. Sampling your coworkers or family members or neighbors simply because they are there is an example of convenience sampling. Take a moment and review the pros and cons of purposeful sampling and convenience sampling. As I bring this presentation to conclusion, I'll leave you with some thoughts on rules of thumb regarding research and particularly sample size. For different types of research, rule of thumb can be used to determine the appropriate sample size. And in saying all that, I leave some questions for discussion. First, what sample size will reach saturation or redundancy? That is, how large does the sample need to be to allow for the identification of consistent patterns? And lastly, how large a sample is needed to represent the variation within a target population. That is, how large must a sample be in order to assess an appropriate amount of diversity or variation that is represented in the population of interest. I hope that you have found something interesting and even more useful throughout this presentation as we all work to narrow down our research approach at, as we get closer and closer to writing our dissertations. I look forward to moderating any feedback that you all may have. Thank you.